We're going to start our work now with rational expressions, and a little congratulations are in order. If you've made it this far, you must be doing something right in the course and passing your test and that. So congratulations. It's a lot of material to learn, and it's nice to see you here. Want to reduce to lowest terms, and I have this rational expression right here. I reduce this to lowest terms in the same way I would reduce a fraction to lowest terms, and that is by first factoring the numerator and denominator completely. I see that this numerator has a 10 common to each term, so I'll factor it out and write down what's left, a plus 2. The denominator has a 5 common to each term. I'll factor it out and write down what's left, a plus 2. So my factors in the denominator are 5 and a plus 2. In the numerator, I have a factor of 10 and a plus 2. 10 factors further into 5 times 2, so I'll divide those 5's out. What's left is 2. These two factors I'll divide out by drawing lines through them like that, and so what's left is just the number 2. So this rational expression right here reduces down to just the number 2. And I do that reduction by factoring the numerator, factoring the denominator, and then dividing out any factors that they have in common. Now, those are the only kind of factors, those are the only things that you can divide out from the numerator and denominator, and that is common factors. It has to be multiplication here between the items in the numerator for us to do that dividing out. Let's try another problem. Here I have two polynomials, the ratio of two polynomials, this one to this one, so this is a rational expression. I want to reduce it to lowest terms. I'll begin by factoring the numerator by taking an x outside and writing down what's left, x squared plus 3x minus 4. The denominator I'll also factor an x out, and what's left is x squared minus 16. Now I want to factor completely, and I see that this trinomial may factor again itself. If it does, it factors into the product of two binomials, so I'll have an x and an x to multiply and give me x squared. And how about positive 4 and minus 1? Inside I have 4x, outside minus 1x. They will add up to positive 3x. The denominator, it will be x times x squared minus 16 is the difference of two squares, factors into x plus 4 times x minus 4. Now I look for common factors for the numerator and denominator. I can divide out those x's. I can divide out the x plus 4's. What's left in the numerator is the factor x minus 1, and in the denominator the factor x minus 4. So that's the reduced form right here of this polynomial. Now if I was to take a number, say, like 10, and substitute it for x in this expression, and substitute it for x in this expression, I would get the same two numbers out, because this expression is equivalent to this one for any value of x. Now you want to be sure here that you don't try to divide these x's out. They're not factors right here, they're terms. It's only a factor if it's multiplied times everything else there. And we can only divide out factors common to the numerator and denominator. Here's another problem. Let's look at the numerator first and see if we can factor it. Looks like 2x squared minus 12x plus 9. The first term and the last term are perfect squares, so let's try 2x minus 3 quantity squared. 2x times negative 3 is negative 6x, doubled is negative 12x, so that works. This is the difference of two squares in the denominator, so I have 2x plus 3 times 2x minus 3. So I'm going to divide out the 2x minus 3 in the denominator with one of the factors of 2x minus 3 in the numerator. What's left then in the numerator is 2x minus 3, and what's left in the denominator is 2x plus 3. So that's the reduced form of this rational expression right here. Now again, you don't want to try to divide out these two x's or these 3's. They're not factors, and so we can't divide them out. We can only divide the numerator and denominator by factors they have in common. Also, 2x minus 3 quantity squared is the same as 2x minus 3 times 2x minus 3. So I divided one of those factors of 2x minus 3 out, and what was left is 2x minus 3 in the numerator and then 2x plus 3 in the denominator. So that's how we go about reducing rational expressions to lowest terms.